So let's look at nonmetals and their compounds. Nonmetals and their compounds. So nonmetals are elements which form negative ions by gaining electrons. Now the number of electrons gained is called its valency. A typical example of a nonmetal is chlorine. So chlorine gains an electron to become the chloride ion. Alright. So nonmetals are called electronegative. Alright, because they form negative ions. They ionize by gaining electrons to become anions. Okay, so this is the chloride ion. So its valency is 1. Its valency is 1. Okay. Alright, so now let's look at the general properties of nonmetals. General properties of nonmetals are 1. They have oxidizing properties. Okay, because they can accept electrons and become reduced to negative ions. So nonmetals can accept electrons and become reduced to negative ions, so they have oxidizing properties. So they're basically good oxidizing agents. Now the oxidizing strength is as follows. So the fluorine is more oxidizing than chlorine than bromine is more oxidizing than iodine than oxygen more oxidizing than sulfur, phosphorus, nitrogen, and carbon in that order. Alright, so general properties of nonmetals: they have strong oxidizing properties in this order. Okay, fluorine is the most has the highest oxidizing strength, and carbon has the least among the nonmetals. Number 2 general property of nonmetals is their displacement of other nonmetals from a compound. Of course, this is based on oxidizing power. So in this reaction, see chlorine displacing bromine from hydrogen bromide to form hydrogen chloride plus the bromine gas. The same thing, bromine has a more oxidizing power than iodine. So it displaces the iodine from the potassium iodide to form this. Now let's look at the first nonmetal, chlorine. Alright, so chlorine, as I said, is very reactive and hence found combined with other elements, especially sodium chloride. Sodium chloride is a typical compound of chlorine. Alright, so to produce chlorine, it's a reaction between concentrated HCl and KMnO4. This potassium tetraoxomanganate 7. So reacts, that's a reaction, and this is set up like that, and so chlorine is gotten from that reaction. So the chemical reaction looks something like this. So that's it. That you get. So chlorine is your important. All right. So right there we have the setup, the apparatus setup for the manufacture or production of chlorine. So that's the balance reaction. Potassium permanganate plus hydrochloric acid. So the chlorine is a greenish yellow gas. The greenish yellow gas is passed through water, first of all, to purify it of hydrochloric acid, and concentrated tetrasulfate 6 to dry it. Okay, so it's collected by downward delivery or upward displacement of air, as chlorine is denser than air. So we'll look at the chemical properties next. So talking of chemical properties of chlorine gas, it has action on metals to form metallic chloride. So we have the reaction between the metal aluminium and chlorine gas, so to form the metal chloride. Then we also have the bleaching action of chlorine on damp litmus paper, okay, and wet flowers. So chlorine with damp substances produces the acid and the hypochlorous acid. So this is hydrochloric acid and hypochlorous acid. And what happens is that the hypochlorous acid releases oxygen. So chlorine this hypochlorous acid basically oxidizes, okay, and makes and dyes the color. So that's the bleaching action of chlorine. It has this tendency to combine with the water in the substance and then release oxidizing. It oxidizes this. The oxidizing action of chlorine bleaches to make something colorless. So it bleaches the substance, such as damp litmus paper or wet flowers. So it turns starch iodide paper blue. It turns starch iodide paper. So that's the chemical reaction: chlorine plus chlorine glass plus that to give it turns it blue. So it's also, like we said, it's an oxidizing agent. So look at the various reactions of chlorine. All right, to oxidize, that's to remove. All right, so those are the various reactions, oxidizing reactions of chlorine. So basically, it's increasing the oxidation state of other substances while itself is being reduced. Okay, so these are the various reactions. All right, so let's look at the uses of chlorine. We've seen that it's a bleaching agent. That's it decolorizes certain substances using its hypochlorous acid for that. So it's a germicide, that means it kills bacteria or germs. So it's a weed killer. It's used in the manufacture of hydrochloric hydrogen chloride gas. It's used for water treatment, sewage treatment, disinfection. Right, so let's look at the preparation of this is a compound of chlorine. We are looking at chlorine and its compounds. So this is a typical compound of chlorine, hydrogen chloride gas. So it's hydrogen chloride. The gas form of this is hydrogen chloride, while the liquid form is hydrochloric acid. So it's basically a reaction between sodium chloride salt and concentrated H2SO4. So to produce sodium hydrogen sulfate and then hydrogen chloride gas. Okay. So the physical properties are it is colorless. Hydrogen chloride gas is colorless. It's denser than air, so that's why it's prepared this way. It's denser than air. That means heavier than. All right. So we said that it is this how hydrogen chloride gas is delivered because it's denser than air. Okay. So this is called the downward delivery. Okay, or upward displacement of air. All right. So it's denser than air. It's also very soluble in water. Hydrogen chloride gas is very soluble in water. That is what we observe in the fountain experiment. So look up the fountain experiment. Basically, this demonstrating that HCl gas, hydrogen chloride gas, is very soluble in water. Now the chemical properties of HCl are acidic. It's an acidic gas, so it basically turns litmus paper red. It does not support combustion. All right, so still looking at the chemical properties of hydrogen chloride gas, it forms white fumes in moist air of its liquid counterpart. So it forms white fumes in moist air. Okay, so it also forms white fumes of ammonium chloride with ammonia. So hydrogen chloride gas forms white fumes of ammonium chloride with ammonia. Okay, that's a reaction there. When it reacts with ammonia, it forms these white fumes of this. So hydrogen chloride gas is covalent and dissolves in non-polar solvents like toluene and chloroform. Because so covalent, and covalent. Okay. All right. Okay. So it's important to note that hydrochloric acid is formed when the hydrogen chloride gas is dissolved in water. Okay, that's basically how hydrochloric acid is formed. So when you dissolve the gas form in water, you get the liquid form. Okay, so hydrogen chloride gas dissolves in water to form hydrochloric acid. All right, let's look at another non-metal, nitrogen. So nitrogen is a gas at room temperature, and of course, it's relatively unreactive. It is 78% of our air, and also occurs in compounds like ammonium sulfate and sodium nitrate. All right, so let's look at so basically in sodium nitrate, if you heat ammonium nitrate, you get the nitrogen gas and water. Okay, now let's look at the preparation of nitrogen from air. So basically it's you're just separating. Okay, so you have the air, it's separating. So first of all put the air. Water drives air out of the aspirator. So water is used to drive air out of the aspirator. So this is the aspirator bottle. So your air comes in here, and then sodium hydroxide absorbs carbon dioxide, and then we have heating through copper turnings to absorb oxygen. All right, so water drives out the air from this aspirator bottle. So the air passes into sodium hydroxide in this second vessel. The sodium hydroxide basically absorbs carbon dioxide from air. Then what is left is passed through heated copper turnings. Okay, so copper pieces of copper The purpose of passing it through the copper is to absorb oxygen, so that you have mostly nitrogen, which is basically insoluble in water. So the rare gases, we have some rare gases present. Remember, in air we have some rare gases like argon. So the rare gases present makes the atmospheric nitrogen denser than pure nitrogen. Okay, so the nitrogen gotten from this process is denser than pure nitrogen because of, we still have some rare gases in that in this nitrogen produced. Now, properties of nitrogen. Nitrogen is colorless, odorless, and tasteless. Nitrogen is basically COT, colorless, odorless, and tasteless. Of course, you can see it's insoluble in water, so that's why it's prepared over water, so it's soluble and bubbles up here. It's lighter than air, okay, because it has been deprived of its other elements. It's negative to all common tests for gases. Alright, so still talking on properties of nitrogen. Nitrogen forms nitrides with these metals. It reacts with magnesium, calcium, aluminium, and iron in different cases to form nitrides. So this is the reaction between nitrogen and magnesium to form the nitride. Alright, so uses of nitrogen. Nitrogen, of course, in the Haber process, that's the production of ammonia. Nitrogen, of course, makes atmospheric oxygen inert, okay, because nitrogen is negative to all common tests for gases. It is makes atmospheric oxygen inert. It is a salt. So still talking about the uses of nitrogen. Nitrogen is a source of fertilizer, okay, by bacteria fixing, okay, the process which bacteria utilize nitrogen in the soil. Okay, so source of fertilizer. It is also used as a refrigerant. Nitrogen is also used in light bulbs to prevent oxidation. Now let's look at another compound of typical compound of nitrogen, which is ammonia. Okay, NH3. Now ammonia is highly soluble and has a pungent smell. So our urine, of course, has a lot of. So yes, ammonia has a pungent smell. Just think about our urine. Our urine is contains high ammonia contents. That's why it has a bad smell. All right. So we have lab preparation of ammonia gas. How is it prepared? Of course, you heat a combination of ammonium chloride plus calcium hydroxide. So this is the reaction, chemical reaction. So under action of heat, okay. Now the flask is tilted to prevent water from getting back, hot water from getting back and cracking the flask, because the point of the problem is hot water there. And so you have the calcium hydroxide is okay. So in the preparation of ammonia, the lab preparation, that is, this is the reaction. So this is the setup. The flask is tilted so that water does not seep back, hot water doesn't seep back to crack the glass. So the ammonia that is prepared is dried using calcium oxide. Calcium oxide is a drying agent, so it is lighter than air, so it has to be collected this way. Ammonia is lighter than air, so ammonia reacts with T6 and calcium chloride drying agent. So that's why we're using calcium oxide as a drying agent. So we don't use this H2SO4 or calcium chloride as drying agents. Alright, so let's look at the physical properties of ammonia. Ammonia is colorless. It has a choking, pungent smell. It's less dense than air. That's why it's produced by the upward displacement. Okay, it's less dense than air. Now let's look at the chemical properties. It's an alkaline gas. Yes, it's the only alkaline gas. It's therefore turning moist litmus blue. It's highly soluble, as seen also in the fountain experiments, just like hydrochloric acid. The test for ammonia is that it reacts with hydrochloric acid to form white fumes of ammonium chloride. Alright, let's look at the industrial preparation of ammonia now. Industrial preparation, we use that's the Haber process. Okay, so industrial preparation. In the Haber process, the hydrogen gas comes from the cracking of alkanes. All right, when you crack alkanes, you have hydrogen gas as one of the byproducts, and the nitrogen comes from the fractional dissolution of air. We've looked at air, okay, briefly, and so the nitrogen is from the fractional dissolution of air. Now, how is ammonia produced? Is produced under one, high pressure of between 200 and 500 atmospheres, low temperature, okay, of about 450 degrees centigrade, relatively low, okay, and ion catalyst is used. All right, so still on the Haber process. Now the uncombined gases, that is nitrogen and hydrogen, which do not combine in this process normal. The uncombined gases can also be recycled. Okay, so use of ammonia gas is used in laundry to remove temporary hardness of water. Ammonia is used in the manufacture of nitric acid. Okay, it's used as an industrial refrigerant. Okay, that's a coolant. Now it's also used to make hydrazine. Hydrazine is used as rocket fuel. Ammonia is also used as fertilizers. It's also used as cleaning agents and to neutralize nitrogen oxide. All right, so these are some of the uses of ammonia gas. Now let's look at other compounds of nitrogen, such as its oxides. So oxides of nitrogen include nitrogen 2 oxide. Nitrogen 2 oxide has a sweet, sickly smell. It supports combustion. And nitrogen 4 oxide is a reddish brown gas. And then we have nitrogen 1 oxide. Nitrogen 1 oxide is popularly known as a laughing gas. It induces laughing as laughing gas and is neutral to litmus. Now, hydrogen trioxide nitrate 5 as an oxide of nitrogen attacks most objects except